some basic concepts in chemistry. Let us first look at the laws of chemical combination. The first law is the law of conservation of mass given by Antoine Lavoisier. This law states that in all physical and chemical changes, mass of reactants is equal to the mass of products. So if we consider a reaction such as the burning of carbon, in which carbon plus oxygen gives us carbon dioxide, according to the law of conservation of mass, the total mass of the reactants is equal to the mass of the products. So carbon plus oxygen, the mass of carbon plus oxygen is equal to the mass of CO2 that is formed. This law also states that matter can neither be created or destroyed, it can only be converted from one form to another. The second law of chemical combination is the law of constant composition. This law was given by Proust. Now what this law states is that a chemical compound is always found to be made up of the same elements, combined together in a fixed proportion by mass. So if we look at a simple example of water, which is H2O, water is always composed of 2 hydrogen atoms and 1 oxygen atom. Therefore, following this law saying that a compound is made up of the same elements and in a fixed proportion by mass, it was observed that irrespective of the sources of water, it always contained 88.81% of oxygen and 11.19% of hydrogen by weight. And hence this law is proved that water always combines in the ratio of 8:1. 8 for hydrogen and 1 for oxygen, that is 88.8% oxygen and 11.9% hydrogen, and this is the law of constant composition, or we can also call it the law of definite proportion. The third law is the law of multiple proportions. Let us first consider a reaction in which we have carbon plus oxygen giving us carbon dioxide, and another reaction in which we have carbon plus oxygen giving us carbon monoxide. The law of multiple proportions states that when two elements combine to form more than one compound, so I have the same two elements combining to form more than one compound. The mass of the element B that combines with a fixed mass of A can be expressed as a ratio of whole numbers. So if I take a fixed mass of A, that is, if I take a fixed mass of carbon and I have a varied mass of oxygen, then the varied mass of B is in simple whole number ratio. Let me consider a reaction in which 1 gram carbon reacts with 1.33 grams of oxygen to give me carbon monoxide, and another reaction in which I have the same 1 gram of carbon reacting with 2.66 grams of oxygen to give me carbon dioxide. As per the law of multiple proportions, my weight of carbon is the same, so my weights of oxygen will be in simple whole number ratios. That is 2.66 divided by 1.33, which will give me a simple ratio of 2:1. And this proves the law of multiple proportions. The law of multiple proportions was given by Dalton. Four is Gay-Lussac's law of combining volumes. French chemist Joseph Gay-Lussac studied number of gaseous reactions and discovered that there is a definite relationship between volumes of gaseous reactants and that of gaseous products. According to Gay-Lussac's law, when gases react together to produce gaseous products, the volumes of reactants and products bear a simple whole number ratio with each other. This is provided that the volumes are measured at the same temperature and pressure. Let us look at an example to understand this better. Under identical conditions of temperature and pressure, I take a reaction in which hydrogen reacts with oxygen and gives me water. Under identical conditions of temperature and pressure, if there are 2 liters of hydrogen combining with 1 liter of oxygen, I get 2 liters of water. So as Gay-Lussac's law states that when gases react together to form gaseous products, the volume of reactants and products bear a simple whole number ratio. That means the reactant and the products bear a simple whole number ratio of 2:1:2. Note that water here is steam. Also note that Gay-Lussac's law, the properties or the volumes are not additive. What I mean by this is that 2 plus 1 does not give me 3. The law only states that the volumes of the reactants and products are in a simple whole number ratio. Let us look at Dalton's atomic theory. (1808). Dalton suggested that matter consists of indivisible atoms. The meaning of indivisible: divisible means to divide, in means not further divisible. So we could not divide atoms. He suggested that atoms of a given element have same mass or identical mass, and atoms of different elements obviously have different mass. He suggested that compounds are formed when atoms combine in a fixed ratio. And atoms can neither be created or destroyed in a chemical reaction. These were the postulates of Dalton's atomic theory. Let us look at the concept of an element. An element consists of only one type of particle. So an element is nothing but a pure substance. An element can further be divided into atoms as well as molecules. Example of an atom is iron, copper, etc. Example of a molecule would be H2, CO2, etc. Let us look at the definition of atomic mass. Atomic mass is the average relative mass of the atoms as compared with a carbon-12 atom. So it is the average relative mass. As compared to C12 or carbon-12. Let us look at molecular mass. Molecular mass is nothing but the average relative mass of molecules as compared with a C12 atom. So the only difference between atomic mass and molecular mass is that atomic mass is the average relative mass of the atom, whereas in molecular mass, it is the average relative mass of the molecule. Let us look at a very important concept called mole concept. First, let me look at what is the meaning of molar mass. Molar mass is nothing but the atomic or molecular mass in grams. So molar mass is nothing but the atomic or the molecular mass in grams. So if I have the atomic mass, rather the molecular mass of oxygen, O2, which is 32 AMU. This is the molecular mass in AMU. If I have to write the molar mass of O2, it is nothing but 32 grams. It is important, this gram term is important because we need to have measurable properties in our laboratories, and AMU is too small a unit to be used, and therefore the concept, mole concept, has been introduced. So another example would be the molecular mass of carbon dioxide is 44 AMU, and the molar mass of carbon dioxide is nothing but the molecular mass but in grams. Now we commonly use the term 1 dozen. 1 dozen means 12 in number. So whenever I say 1 dozen eggs, 1 dozen apples, I know that it is 12. So if I say 1 dozen eggs, I mean 12 eggs. Similarly, in chemistry, we have a word to tell us about a number. That is 1 mole. 1 mole is nothing but 6.022 into 10 raised to 23 atoms, molecules, or ions. So if I have 1 dozen eggs, I have 12 eggs. So if I have 1 mole of eggs, I have nothing but 6.022 into 10 raised to 23 atoms, molecules, or ions. Hence, we can define a mole as the amount of substance which contains Avogadro's number, that is 6.022 into 10 raised to 23 atoms, ions, or molecules. Mass percentage of an element or percentage composition of an element is nothing but the mass of an element in the compound divided by the molar mass of the compound into 100. Let us look at an example. Consider a molecule ethanol which is C2H5OH and its molecular mass is 46. There are 2 atoms of carbon, so the mass of carbon is 2 into 12, that is 24 grams. There is 1 atom of oxygen, and so that would be equal to, so this is for carbon, oxygen would be 1 into 16, that is 16 grams. And we have 6 atoms of hydrogen, 5 plus 1, 6. So my hydrogen would be 1 into 6, that is 6 grams. If I want to find out the percentage of carbon, I use my formula mass of element upon molar mass into 100. My mass of carbon is 24 grams. I divide it by the molar mass of my compound, which is 46 grams, into 100. Therefore, my percentage of carbon in the compound is 52.17%. Let us look at empirical formula and molecular formula. Empirical formula is the simplest whole number ratio of various atoms present in a compound. And the molecular formula shows the exact number of atoms present in the compound. For example, I have benzene, which consists of 6 carbon atoms and 6 hydrogen atoms. So C6H6 would be the molecular formula of the compound. The simplest whole number ratio, 6:6, is nothing but 1:1. So C1H1 would be the empirical formula for benzene. If I have another example, C2H6, where there are 2 carbons and 6 hydrogens actually present in the molecule, this is the molecular formula. 2:6 is nothing but 1:3. So if I have CH3, this becomes my empirical formula. Molecular formula can be found out by the formula N into the empirical formula. Is nothing but N into where N is any integer. That is 1, 2, 3, etc.